Hi, welcome to my science tutorial. In today's video, we're talking about rate equations and we'll also look at the calculations involved, how to go about them. Now, before we proceed, we have a video on the rate law equation. If you haven't seen that, then you can check it out in our playlist. In our previous video, we did mention that the rate law equation is derived from what we call the rate determining step. Rate determining step, in short RDS. Okay, so we know that this RDS, or rate determining step, is the slowest among series of reactions that take place to complete a main reaction. So it's the slowest. And then we look at a general equation such as this: A plus B, and then our A has X and the B has Y, giving us a product. And we see that if we have something like this and we want to write the rate equation, then the rate equation is going to be given by R is equal to K, and then we have the concentration of A raised to the power X and the concentration of B raised to the power Y. Alright, so we look at that and we said the R here is our rate, the K is a specific constant rate, that's the constant, and then the A and B are the reactants, and then we have the X and the Y being their mole. Alright, so X is the order of reaction with respect to reactant A, and Y is the order of reaction with respect to reactant B. And then when we add the two, X plus Y, we have what we call overall order of reaction. Overall order of the reaction. Alright, so there are some few things we have to take note of before we proceed. And the first thing is that if let's say if a particular reaction is not said to be the rate determining step, then their respective moles, in this case X and Y, cannot be given as the order of the reaction. It means the order of the reactants over there has to be determined experimentally. So when we have an equation such as A plus 2B giving us a product D, and if they say this reaction is not an RDS, then we can't write the rate equation to be R being equal to K, and then we have our reactant A, and then we have B raised to the power 2. No, this can be our rate equation. Alright, how then do we write it? You write it with a general formula, which is R given as K to the X, B to the Y. So X and Y will be determined experimentally. Another thing we have to take note of is what we call the molecularity. This is talking about the number of reactant species. What is reactant species? Like atoms, molecules, and or ions. That's actually are found in the rate determining step. Okay, so we can just put it this way and say that it is the number of reactant species that take part in the RDS of a given reaction, in the rate determining step of a given reaction. So if we have the reaction B plus A2 to give us BA2, and then if the rate determining step of this reaction is if RDS is BA plus A2, giving us our BA2 plus A, then in this case we will say that the molecularity is 2. Molecularity is equal to 2, because talking about the reactant species, we have the atom B, and we also have the molecule A2, so that means our molecularity is 2. Now another thing we have to take note of is that anytime we have a rate equation and there is and one of the species does not appear in it, I'm talking about the reactant species, if it doesn't appear in the equation, then that means that that particular reactant, or we can say the order of reaction with respect to that particular reactant is 0, and so we will not see that in the rate equation, and that simply means that the reaction rate does not depend on that particular reactant. Now if this reaction A plus 2B given us D, if this reaction is a rate determining step and you write the rate equation, R giving us K, concentration of A, and that of B to the power 2, then we know that the mole of A is to the power 1, so we won't write that one there. And if B is 2, if the mole of B is 2, we write the order to be 2. So the order of the reactant A is 1, and so we'll call it first order reactant. And if we talk about B being raised to the order 2, then we'll say that B is a second order reactant. What if it is to the power 3? They will call it third order reactant. Now there are some important things we have to note for a first order reaction. We're talking about things like having a rate like R equals K, the concentration of A to the power 1. Then when we increase the concentration of A by n times, then definitely we're going to have the rates of the reaction also increase by n times. So our rate here is going to be n Okay, so if our initial rate is R, then let's call our final rate after increasing the concentration R1. So in this case, when you observe, we can then say that our R1 is equal to NR. That is N times the initial rate of the reaction. Now, what about a second order reactant? If we have our rate being equal to K, and then we have the square bracket of A to the power 2. What if the concentration of A is increased by n times? If our R is this, and then it is increased by n times, then what is going to be our R2? Our R2 is going to be n to the power square. So when we have r2 to be equal to n squared k square bracket a to the power 2, then we can see that our r2 is equal to n squared r, because we know that our r is equal to k square bracket n a to the power square. So this simply means that our r2 is equal to n squared r.